In this video, we're going to explain how to combine vectors mathematically using something that's called the component method. So to begin with, I'm just going to review the steps on this first slide, and then we'll go through a problem. Okay, so step one. Step one is to compute the x and y components of each vector, organize them into a table. And one very important thing that I'll stress in the subsequent slides is that if an x component is acting to the right, it's got to be positive, and if it goes to the left, it's got to be negative. And likewise for the y-axis, if a y component is pointing upward, it's positive, and negative if it's downward. And then you'll see in this next example, it's probably the easiest way to do this is by drawing the vectors with their tails at the origin. Okay, so then step two is to compute the algebraic sum of the x and y components. This is just a matter of adding them up. Then step three is to plot out the x and y components on the xy coordinate system. Then to get the magnitude of the resultant, we use Pythagorean theorem, and then right triangle trigonometry to get the direction of the resultant. Okay, so here is the example problem. We've got a man who walks 5 kilometers north, then 8 kilometers, 35 degrees west of south, and then 6 kilometers, 45 degrees north of east. We want to find his resultant displacement. Just one point here, that this technique that we're going to review right now applies to the resultants of any vector. It might be displacements, it might be velocities, it might be forces, whatever. But the technique for combining the vectors is the same. Okay, so I've got the vectors right here, drawn out on the xy coordinate system. Here's vector A, acting in the northerly direction. Then this one I'm calling vector B, which is 8 kilometers, 35 degrees west of south. Here's south, so this angle in here is 35 degrees. And then finally, the third one, which is 6 kilometers, 45 degrees north of east. So this angle in here is 45 degrees. Okay, now we're going to be using a little bit of trigonometry, and you've got to remember your sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. This is a little acronym here, SOHCAHTOA. In case you don't have that committed to memory, if you just remember this name, that should help you recall those three formulas. Okay, so now we're going to take each one. So vector A. Now vector A is the easiest one because that's acting directly north. So if it's acting directly north, then its x component is 0. There's no component of this along the x-axis. And the y component is its whole magnitude of 5 kilometers. Notice that this is positive because that vector is acting upward. Okay, so now we move on to vector B. Vector B is 35 degrees west of south. That's this one right here. Okay, so we've got to compute the x and y components starting right here. This is the x component. Okay, so this angle is 35 degrees. So sine of 35 is equal to bx, the x component of b, divided by the hypotenuse being the length of that, which is 8 kilometers. So I've got that written here. We solve for bx simply by multiplying both sides by 8, and we get that. And so we end up with negative 4.6 kilometers. Again, remember, Bx is going to be negative because it's acting to the left. Okay, now we go on to the y component of B. Okay, so that's right here, y component. So that's going to be cosine 35 equals minus by, it's acting downward, divided by 8. So solving for by equals minus 8 times cosine 35. Work that out on your calculator, negative 6.6 kilometers. Okay, now we're down to vector C, which is this one right here. So the x component right here is going to be cosine 45 equals cx over 6, 6 being the magnitude of that vector and the hypotenuse here. We solve for cx, 6 times cosine 45, which is 4.2 kilometers. Notice that's positive because that x component's acting to the right. And then the y component, we use sine 45 equals cy over 6. Solve for cy also being positive because it's acting upward. That is also 4.2 kilometers. And of course, that's the reason why they're both the same is because sine of 45 and cosine of 45 are the same values. Okay, so here all I've done is I've taken those components for A, B, and C and organized them in a table, making sure to keep track of the signs. And then down here, I've taken an algebraic sum of the x and the y components. Okay, so I have the result down here. The sum of the x components, negative 0.4 kilometers. The sum of the y, negative 2.4 kilometers. Okay, so here I've taken the sum of the x and y components and plotted them on the xy coordinate system. So the sum of the x's was negative 0.4, so I've got that pointing to the left, and the sum of the y's was negative 2.4. I've got that acting down this way. Now, notice I've made the x and y components into a triangle. I didn't put the x over here so that I could make it into a triangle. Okay, so my task now is to compute the resultant, which is here, and I can use that, or I can do that by using the Pythagorean theorem. It's a right triangle, okay? So what I need to do is to compute this resultant right here. Resultant is going to be the square root of the sum of the x squareds plus the y squareds. So actually I have them reversed here. This is y squareds and x squareds, but that doesn't really matter. And so square them, take the square root, and the resultant here is 5.9 kilometers. So that's the resultant displacement. Now the final task is to find the direction of the vector. In other words, I want to find out what this angle is over here, how it's acting. And for that, I can use the tangent function. Tangent equals opposite over adjacent. So that's going to be negative 0.4 over negative 2.4. I calculate that out. It comes out 0.17. Then I do an inverse tan on my calculator, and I end up with an angle of 9.6 degrees. That's right here. So that's 9.6 degrees west of south. Here's south, so it's that angle west of south. Now, you can express that direction a couple of different ways. You can express it as negative 99.6 degrees. In other words, starting on the x-axis here and rotating around counterclockwise. Or start on the x-axis, rotate it around that way, in which case you'd come out to be 260 degrees. Or you could express it as this angle over here, which is 80.4 degrees south of west. Now, just one more point I want to make, and that is that it's very important that you practice these problems. You can go through and review this video. Pretty much all of these component problems are done the same way, but it does require practice. So that's my advice to you. Do some of the homework problems, make sure you go through them, and try to be systematic about it so that you can keep all the steps straight in your head.